Hello, statistics students. This video is for chapter 2.5 and 2.6, measure of center and skewness. In this video, we're going to talk about how to calculate a value called center that is most representative of the data sets, kind of like the most typical data. And you can also say this value summarize the data. You use one value to summarize it, and it should be like in the middle or the center of the data set. So that's why we call it center. There's different way of calculating the center, and they each have their pros and cons. The first is mean, the second is median, the third is mode, and the last one is mid-range, which is less common. I'm sure you have heard of mean and median, but let's just briefly go over them and particularly compare and contrast them for using it as a numerical summary of the center. One, mean. Mean is actually the average. In real life or in English, we call it the number that you add together and then divide it, like average it out by adding them and then divide them by the number of data, the average. But in statistics, we have another name for it. We call it the mean. We never use the word average anymore. And there is actually two symbols that represent the population mean is mil, the sample mean is x bar. So if your data, this data value are sample data values, because you get it from a survey, then the mean that you calculate is called a sample mean. If your data is actually all the data value from the whole population because you are doing a census, and these are from population, then your mean that you calculate is called population mean or called mil. X bar, this one is read as X bar, and mil is a Greek letter that read as mu mil. Okay. And this is the formula for calculating them. We know that when we calculate them, we put it in the calculator and then add them and divide, right? So in terms of the formula, the symbol to represent adding all numbers together that you have is sigma. So sigma means adding them together. It's actually a Greek letter, but this symbol represents adding things together. X is all the data values, right? Data value. It changes because every data value is different, so we use X to represent it. There's not just one X. It would be X1, X2, X3. But if you do sigma X, that means all of them. Okay, so the way you calculate them is the same. You add them and divide it by the sample size. If it's X bar, you add them together, sigma X, and divide it by the population size, capital N. Lowercase capital is sample size, uppercase capital is population size. So let's look at some important properties of mean. When you calculate mean, of course, you have to use every data value. It's really representative because every value is involved. But the interesting thing is, although every value is involved because you're averaging it out, if there is one extreme value, extreme could be extremely large or extremely low compared to the rest of the data, the value of the mean changes substantially. And after we talk about these four terms, we will actually do an example to show that. So if you add a number that's really small or really big, the mean changes substantially. And this phenomena is known as not resistant. Okay, mean is not resistant. It cannot resist to go to the extreme. Okay, it can say mean is highly affected by some extreme value, so extreme noise. Okay, the third is if you calculate a sample mean, of course your goal is to use to estimate your meal because you might not be able to do a census. You can use it if your sample is not biased. But if your sample is biased, such as a voluntary response sample, then X bar is not a good estimate for meal. X bar is just X bar. It just represents those or the average of those sample value. The second way of calculating a center is finding the median. Median basically is the middle of the data when data are arranged in order in increasing or decreasing magnitude. Usually we do increasing. To calculate median, you can do it by hand. I'm sure your grade school teacher has teach you that. But it's kind of difficult in that you have to firstly sort your data in order. And then if there's an odd number of data, your median is actually by crossing out the number, the low end and the high end, and then the middle number is the median. Okay, so let's do an example. If I have a 5, 9, 11, 24, I don't want to have all this number, 30. Okay, so these are all, though I have 5 number, that's odd number of data. So to find the median, and you can see that they are in order. So I will cross out one pair, cross out the second pair. Oh, this is the middle. So median is 11. When you have odd number of data values, you always have a middle number. But if I have, so this is set number 1. Set number 2, if I have 5, 9, 11, 24, 30, 37. Okay, so I have even number of data value. I have 6, right? So I would still do one pair cross out, one pair cross out. Oh, I have 2 in the middle. So what is the median? The median is the mean of the 2 number. It's not the 2 number. You cannot have 2 median. So you add them and divide by 2. In this case, is 35 divided by 2 is 17.5. Okay, so that's how you calculate median. You can see that it is not as easy. You kind of need you cannot use a calculator, but some kind of like logic involved. But let's look at properties of median. Compared to the mean, the median does not change. If we add a few extreme values, so just imagine if I add, instead of 37, this is 370, your mean is still 17.5, right? So the extreme data at the end does not affect the median that much, whereas the mean does. So we say the median is resistant. It don't change. It doesn't change. It doesn't move. The third is the mode. The mode is the one that occurs the most frequently. The interesting about the mode is you can actually calculate the mode even if it's a categorical data. So sometimes we say we use 1, 2, 3, 4 to represent color or whatever response that you want. You can actually calculate those response. 1 is yes, 2 is no, 3 is like no, no comment, or those you can even calculate those even if they are quantitative, if they are categorical data. But mean doesn't make sense, median doesn't make sense, but mode is just the most common one. So it tells you that it is the category that occurs the most. The difficulty about the mode is it's very hard to implement it in a calculator. So a lot of calculators don't have it. And also, a set of data can have 1 mode, 2 mode, or no mode. So for example, I have data 1, 2, 3, and 9, 11. So there's no mode because they're all different, right? There's no repeat. But if I have 1, 2, 2, 2, 2, 2, and then 9, 11, so this happens 3 times, happen more than all of them, so the mode is 2, right? And if I have 1, 2, 2, 2, and then 999 also 3 times, and then 11, so you can have 2 mode. The mode would be 2 and 9, right? You can have actually multiple if they have same together. So you can have bimodal, you can have multimodal, and you can have no mode. Okay, when they do not repeat, especially for continuous data, mode does not exist, and a lot of calculator doesn't give you mode. In those cases, you will sort your data and then you just scan through them. Okay, we'll practice doing them in example. Mid-range is rarely used, but somehow it's a suggestion. If you want to find a center and you do not have calculator around, you do not want to sort your data because it's really big. What you can do is do maximum plus minimum divided by 2, kind of the middle of the whole range. So that's called mid-range, which is max plus the minimum divided by 2. So of course, because you have involved maximum and minimum, if there is extreme data, it would change the mid-range a lot. So it is not resistant again, but it's easy to compute. You don't have to calculate so many number and you don't need to sort anything. So in case you're trapped in an island, you need to calculate the center. That would be the one that you choose. So how do you find all these different mean, median, mid-range, and mode? So there's 2 calculators that you can use. One is the LibreText one variable statistic calculator. I'm going to do LibreText no comma, one variable calculator. So that's what I usually do. This one variable statistic calculator from LibreText, and use they expect you to type number with comma in between and to calculate, and that's it. The other one is, of course, that you type the number in column. So usually for me, if I have number in a comma list, I'll use one variable statistic calculator. If I can copy my data in a column, I'll use the statist. Okay, so let's do an example on how to use them. Oh, where's my, here. Oh, and then for mole, I show you a calculator here, but really we don't need to use it that much. But if you want to find mole, there is an online calculator from Calculator Soup, but it has a lot of ads, so I don't usually use them. Usually I just sort the data and find out. Before we do the example, I can talk about the round off rule. That means if I calculate mean, I divide it by something, I would have more than one more. I have decimal places, right? So how do I round it? The typical uh, guideline is to carry one more decimal place than the original data. If one of your data has one decimal place, then your median is one or more than it, so it'll be two decimal places. If all your data are whole number, then you do one decimal place, just one more. For more, you don't need to round because it's the original data. So let's do a mean and median for this. And because these are already in, what is it called, the list mode. Oh, so I'm going to copy and paste it. How come I can't copy and paste? Okay, let me try again. Okay, I can copy the list into, I want to use the one variable statistic calculator and paste it in, and I just calculate. I don't need to check population or sample because by default it's sample. So mean is 80.3, median is 80. You can use it to calculate 5-number statistics also. So you can see if you have some ordinary data with nothing special, the mean and median are quite close, right? Mean is 80.3, median is is it 80? Median is 80. So either one are quite good as a center. But if I have an extreme data, see this is extremely low. You can have an extremely high data also. So what would happen? So let's try to use this. Let's just do 5 here and then click calculate. Wow, the mean changed so much. The mean suddenly becomes 69.6. The median is still 78, doesn't change much. So that is called resistant. So you can see the mean change 69.6 differ so much because it followed the low number. It's not resistant. It is cannot be it can affected by just one number. But the median is not. It's still the last one it was 80, right? Oh gosh. I think this is 78. For some reason, yeah, let me double check. It was, yeah, I think I just, right, the last time was 8. I don't know why I write 78. I miss, I must have done something wrong. So you can see that the mean is not resistant, right? It changed a lot. So if you have extreme data in your data sets, you can delete it because it's not an error. It's just that they have extreme. Then the median is really the middle, not the mean. Does that make sense? Yeah. So we can try if I have a really big number. So for example, instead of using 8, I use 400. Right? What do you think? If I do calculate, the mean changed to very big, 126. But what's the median? Just 82. The median refused to change. It's still kind of in the middle, but the mean, 126, is kind of the second largest. It doesn't represent the middle of the data set. So when you have extreme data, the median is a better center. I can also show you, oh, it's almost time. So I'm going to do an example in the second video.